Hello, welcome back to Chapter 6, Section 3. In this section, we're talking about how to divide a polynomial by another polynomial, dividing polynomials. Now, in the previous video, we showed you how to do it using what we call long division, which is exactly the same as if you divide numbers. And again, polynomials are actually, they are numbers. They just don't look like numbers. But I'm talking about things that actually look like numbers. So if I was going to divide 12,347 by 5 or 15, I would use long division. Okay? And I know you're probably thinking, no, I would use a calculator. And this is one of those cases, God love it, where if we just said, you know what, that's great. Certainly use a calculator if that's the only thing you're going to be doing. And if you don't want to know why this works, just put it in the magic answer box and get it out. But we learn long division so that later we can do things that a calculator is not going to be able to do, or at least not the calculators that I have. So we'll see. So in this video, in this example, what really is going to happen is if you look at the problems, I'm going to pull up. Which one do I want to look at? Let's look at this one. It was the biggest one that we did. This is from the last video. If you look at it, there's a pattern here, okay? So in this column right here, I've got x to the third power. I've got x to the second powers all the way through here. I've got x to the first powers all the way through here. And I've got the constants all the way through here. And yeah, I know up at the top, I also have, I have it shifted over by 1. And I'm thinking that maybe when I get to class, or when we get to class, I can just move that over, but to keep everything lined up. But don't worry about that. But if I look at just this part, everything's lined up. And really, the only arithmetic that I did, so to speak, dealt with the coefficients. So I did 3 subtract 3 is 0. I did 4 plus 6 is 10. And I did 0 plus 20 is 20. And I did 10 plus 40 is 50. So there's arithmetic that's happening with the coefficients. And there's some other things that are happening too. That didn't start out as being positive 6. It actually was negative 6, and then I subtracted it. And same thing with here, and same thing with here. And if you watched that video already, you remember doing all that. Well, after doing long division for enough time, we actually can see some patterns if we ignore the variables and we look at just the coefficients. And that brings us to what we call synthetic division. So in this slide, or this piece of paper I have here, which I'll take a picture of and you can look at it later. I'm not going to go through the whole thing. I'll talk through the examples, but I'm not going to read it. This kind of explains the process, right? Synthetic division just deals with the coefficients. However, I have to remember the things that we had here, okay? It has to be in standard form, and I have to make sure that I include the missing terms. I promise you, you're going to have a problem on the test, or maybe even the quiz, where you're going to have to remember to do the missing terms. So put a star next to that and have that ready to go, okay? And you'll see examples. But here's how synthetic division works. I take the 2x squared plus 7x plus 9 in this example. So I take the polynomial that I'm going to divide, and I just write the 2, the 7, and the 9. And I know I've got other stuff written here, but that's the 2, the 7, and the 9 right there. Okay, so far so good. Then I take the x plus 2, and this is how Dr. Berger does it. I've seen it differently. It doesn't matter. It's just like it's a format, so it's like anything else, formatting could be changed. They do like this little like corner here, and they put a -2 here. Okay, no, wait, where'd the -2 come from? That's because that's not x plus 2. Looks like x plus 2, but it's not. It's actually x subtract -2. That sounds familiar. That's what we talked about a lot when we were talking about horizontal translations. So if I had a function that had parentheses x plus 2 in it, remember we said that's a horizontal translation to the left 2. If you remember that, that right there is h. So there's one of the things that people in the past when I've taught this have forgotten to remember, and I think I was redundant, doesn't matter. They didn't remember, and it caused them to get it wrong. So if this is x plus 2, I have to put a negative 2 here. And if it's x subtract 2, I put a positive 2 here. That's one way of looking at it. Now this goes to the horizontal translations also, and then I'll stop and I'll show you, I'll stop babbling and tell you how to do synthetic division. But also, here's the other part, okay? If I do x plus 2 equals 0, like I'm solving it or finding the zeros, then I get x equals negative 2. That's what I want there. And again, it's the same thing. It comes from, well, that'd be a horizontal translation of a very simple line with a slope of 1. So that's where the negative 2 comes from. So I'm going to point that out every time we do this. Now the process of this is the same as long division, it's just more compact. The first thing I do is I bring down that coefficient, and I say, what do I multiply negative 2 by that equals 2? I'm sorry, excuse me, I said that wrong. What do I multiply negative? I'm saying it in terms of like factoring. Excuse me, I'm factoring in my other classes, and that's why I keep thinking it that way. I take the negative 2 and I multiply by 2, and I get negative 4, and I just put it right there. And then I add. 7 times negative 4 is positive 3. I multiply negative 2 times 3 and get negative 6. And you don't have to rewrite this. They're just showing it like step by step. Then I get negative 6, and then I add 9 plus negative 6 and get 3. And this last part over here, that's the remainder. Okay, so this is the remainder. What's left over after I divide? The 3. So then I write it, the quotient, I write it like this. I take the 2 times x plus 3, and then I take the 3 and write it over the remainder. When we get rid of all of the variables, x to the second power, x to the third power, etc., sometimes we lose track of, like when we want to rewrite this, that's not the answer. This is the answer, okay? So sometimes we lose track of like how to write this. Like why is it 2x plus 3 over x plus 2? Why is it not 2x squared plus 3x plus 3? Or even something different. So one of the things I'm going to point out and try to remind you of this is you can always re-multiply. And if I just look at the first part, 2x times that x, because remember, that divided by that equals this, so if I work backwards, I'm going to multiply. That 2x times that x equals 2x squared. So always check by re-multiplying. All right, let's do a couple problems here. And actually, this is going to go a lot faster. I know I'm already 8 minutes, but this synthetic division, we've included synthetic division in Algebra 2 Accelerated because your pre-calc teachers have asked us to do this, because you're going to be seeing it a lot in pre-calc. So good luck with that. Okay, let's look at this problem. I have x to the 4th power, 2x to the 3rd power, 3x, and this is 3x to the 1st power. So what am I missing? What about x to the 2nd power, question mark, question mark? I have to include the missing terms. So what are my coefficients? My coefficients are 1, negative 2, 0, because I've got 0x squared, 3, and then of course my constant 1. So 1, negative 2, 0, because I have 0x squared, 3 and 1. Just the coefficients. Now, what am I dividing by? Or actually, so I'm dividing by x subtract 3, but what do I put in this corner here? Well, remember, it's the opposite of what I see here. I have negative 3, so think of it as like, you can think of it as x subtract h. So my h is going to be 3. That ties in with what we've done before. Or you can think of it as if I do x subtract 3 equals 0, then x equals 3. So I get 3. And those two things are related. Once you have it set up correctly, everything after that goes fast. Take the 1, put it right here. 3 times 1 is 3. Negative 2 plus 3 is 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3, 9. 3 plus 9 is 12. And 3 times 12 is 36. And finally, 1 plus 36 is 37. Okay, that looks great. I am constantly aware of the fact that my pacing talking to my iPad is probably different than if I was in class. So I'm going to go through this one more time now that you see it. I have the 1, the negative 2, the 0, the 3, and the 1. And I'm going to use 3. Move this down. You can also think of it this way. The book doesn't do it, but I'll do it. You can put a 0 in there. Just start with a 0. Okay? So 1 plus 0 is 1. Got it? Now I take this 3, multiply it by 1, and get 3. And then I add. Negative 2 plus 3 is 1. Take this 3, multiply by that 1, get 3 again. Then I add. 0 plus 3 is 3. Then I multiply. 3 times 3 is 9. Add and get 12. And 3 times 12 is 36. Add and get 37. That actually can happen really, really quick. Adding and multiplying are things everyone's good at this point. That's not the answer, though. I need to find the answer. This part right here is the remainder. Be nice if the remainder was 0. Looks like I said reminder, sorry. That's what happens when you use a thick marker. That means that that's my constant, 12. That 3 is being multiplied by x, 3x. That 1 is being multiplied by x squared, 1 times x squared. And that 1 is being multiplied by x cubed. See how I did that? Constant, x to the first, x to the second, x to the third. My remainder, I'm going to write like this, 37 over x subtract 3. Again, students sometimes have trouble going from here to here. These are the coefficients for my polynomial, and it's in standard form. How do I know what to start with? Well, if I take x to the 4th power and divide it by x, just that first part, I'm going to get x to the 3rd power. So you can think of it, if you're going to go left to right, you can start with the x to the 3rd power and then work your way down until you get to the remainder. All right, pause that if you need to hear me say it again. I'm going to get to work on this one. This one's a little less work. I have x to the 2nd, negative 3x to the 1st. I'll put my exponent in there. And I've got negative 18. This is in standard form, and I'm not missing any terms. So I'm going to write 1, negative 3, negative 18. From the x subtract 6, I'm going to take out the 6. Again, this is x subtract h, so my h is 6. Or you can think if x subtract 6 equals 0, x equals 6. Both of those are valid. All right, now watch this. And again, this is being recorded, so it's not going to disappear. 1, 6, 3, 18, 0. I'm not cheating. I'm not looking at that with my notes. All I did was I added 1 plus 0, and like I said, normally we don't put the 0 in there. I added 1 plus 0 got 1. 6 times 1 is 6. Negative 3 plus 6 is 3. 6 times 3 is 18. Negative 18 plus 18 is 0. Boom. Just like that. Hey, and guess what? I got no remainder. That actually means that that's actually a factor of this. And when I divide, I get x plus 3. Because this is my constant term, and I have 1 times x. And if I think about it, I can actually use this one to check. I can do x subtract 6 times x plus 3. Take that times that, and I'm going to get x squared subtract 3x plus subtract 18. Almost said plus 18, sorry. Excuse me. All right, you're looking at this one going, oh my gosh, it's got a fraction in it. You're fine, you'll be okay. 4x squared subtract 12x plus 9. Standard form, I'm not missing any terms. When I get to this one, that's fine. You will get problems where you're going to have it where it's not in standard form and where it's not missing any terms. But right now we're just practicing, we're just looking at the examples where that's not a problem. So I'm going to write 4, negative 12, 9. 4, negative 12, 9. This is x subtract negative 12. So I'm putting, I said negative 12, negative 1/2, I'm sorry. When I'm making these videos, I'm thinking about like 3 or 4 things at the same time. Sorry about that. That's no problem, you can do this. So again, if I put my 0 here just to start, 4 plus 0 is 4. Now I'm going to multiply these two things. Negative times positive is negative. Half of 4 is negative 2. Add these two. Add this column. Negative 12 plus negative 2 is negative 14. Negative times negative is a positive, and half of 14, or 1/2 times 14, is 7. Now I'm going to add this last column. 9 plus 7 is 16. That is not my answer. I have to now change this into the other polynomial. And keep in mind, if I have something times x to the second power, and I'm going to divide it by x to the first power, that means I'm going to have x, something times x. All right? So I get 4x subtract 14 plus 16 divided by x plus 1/2. Now, normally we don't put fractions inside fractions. That comes up in a later lesson, so don't panic about that right now. If you show this to someone who's gone through this class already and they're beyond Algebra 2, they're probably going to go, but tell them it's okay for now, right? Last one for this video. So you got standard form, it's not missing any terms, 6, negative 5, negative 6. This is x plus 3, so it's actually x subtract negative 3. Put a negative 3 here. Put that 0 right there. 6 plus 0 is 6. Negative 3 times 6 is negative 18. Negative 5 plus negative 18, I think, is negative 23. And negative 3 times negative 23 should be positive 69, I think. And subtract, negative 6 plus 69, I think, is going to be 63. So my quotient, the polynomial, is going to be 6x subtract 23 plus my remainder over the x plus 3, as written as a fraction for the last part. Now, that's the end of this video, and again, I apologize, it's another long one. For all of these, you can always check your answer by remultiplying. All right? So if you get something and you're a little confused about whether or not you got it right, then just remultiply it. Take 6x, subtract 23, I'll talk about the remainder in a second, and multiply that by x plus 3. 6x, negative 23, x plus 3. I get 6x squared, that's good. 6 times 3 is 18x. This is negative 23x. And 3 times negative 23 was what, negative 69 again? So 6x squared, check. Negative 23 plus 18 is negative 5x, check. And this is where the remainder comes in. If I multiply the last part, 63 over x plus 3, and I multiply that by x plus 3, then that's just going to give me 63. And 63 plus negative 69 is negative 6. So, and I could have done that for all of them. So you can always go back and remultiply and see if you got it right. I will see you in the next video.